This lesson is on relativity and normalization. So what is relativity and normalization in the context of looking at baseball statistics? It can be used when making comparisons between and among players, teams, and eras. This helps to quote-unquote level the playing field when comparing statistics and can help determine whether it was more difficult for Babe Ruth to hit home runs in the 1920s or Sammy Sosa to hit home runs in the 1990s. It transforms raw statistics into a new number, and we take it out up to 4 decimal places. For example, we're going to look at Ralph Kiner, player with the Pittsburgh Pirates in 1947. That year, he hit 51 home runs in 565 at-bats for a home run to at-bat ratio of 51 over 565 or .0903. That shows that he hit about 9 home runs for every 100 at-bats normally. In the major leagues in 1947, all players hit 1,565 home runs in 84,436 at-bats. Take the home run number divided by the at-bat to get .0185, or showing the average player hit just under 2 home runs per 100 at-bats. So there you have their relativity, their normalization numbers. Ralph Kiner, .0903, and the league that season, .0185. You divide Kiner's number by the overall number, and you get 4.8689. So what does that number say? What can we learn from that? One possibility to take from it is Kiner was nearly 5 times better than the average home run hitter of 1947. By figuring the relativity and normalization numbers out for various statistics, you can compare players from different eras, or even narrow down between the American League and the National League. Like we discovered when we looked at runs scored, that there are more runs scored in the American League than there are in the National League. So these relativity and normalization numbers can even help compare how a player might do when they're in the American League versus when they're in the National League. We're going to go through some other examples here. 1928, Hall of Famer Heine Manush had a slugging percentage of .575. If the slugging percentage of the American League was .397, find his normalized ratio and give an interpretation to this number. So to do that, again, you take the player's number and divide it by the league's number, and you get 1.4484. Manush was nearly 45% better than the average American League hitter in 1928. Generally, any normalized offensive number greater than 1 means the player was better than the average player. Below 1 means below average, and 1 is average. Looking at some more examples, at the end of the 1959 season, the American League home run hitter Rocky Colavito of the Indians was traded for the American League batting champion Harvey Kuhn of the Detroit Tigers. Compare their relative performances using normalization and given the following information. Kuhn had an average of .353 while the league batted .253. Colavito had 42 home runs and 588 at-bats, while the league had 1,091 home runs and 41,464 at-bats. This is sort of a two-part question. We figure out Kuhn's normalization number. That is .353 divided by .253 for a normalization number of 1.3953. Colavito's, first we have to figure out Colavito's home run to at-bat ratio. That's .0713. The league's ratio that season was .0260. You divide those two numbers to get 2.7462. Can any conclusions be drawn from comparing these two numbers? You could look at Colavito and say, well, he's more than 2.5 times better than the average home run hitter, while Kuhn is about 40% better in hitting for average from that season. So which team won the trade? This is more to show that it's difficult to compare separate stats when you're looking at these, but you can still glean some information. Is batting average more important, or is power more important? Now we're going to look at pitchers, at a number of Hall of Famers: Walter Johnson, Bob Feller, Juan Marichal, and Bob Gibson, from a variety of different eras. And here we have their earned run averages for each one. So if we compare the individual ERAs to the league ERAs, the lower ratio is the better ratio. So for Johnson, we have .3891, Feller .5959, Marichal .6194, and Gibson .3746. So that is dividing their ERAs. So back on this page, Johnson, we divided by 1.14 divided by 2.93 to get his .3891 number. Conversely, if you're looking at pitching, you can reverse those two numbers. You can divide the league number divided by the player's number, and you would get here that Johnson and Gibson are more than 2.5 times better than the league during their given years. Obviously, Feller and Marichal were tremendous as well.